The discovery was made by researchers, an astonishing discovery deep within these cosmic entities. At the core of these ancient celestial beings, they've unearthed something both awe-inspiring and chilling. Within a black hole, this finding puts an end to all previous beliefs about these cosmic marvels. Prepare yourself as we demonstrate the enticing mysteries concealed in the heart of a void. If you want to remain informed about the latest developments from the universe and its surroundings, don't forget to subscribe to our channel, like, and share this video with others so it reaches a greater number of people. Also, hit the notification bell. Black holes have always been a captivating subject. As theorized by the brilliant physicist Albert Einstein in his general theory of relativity, the gravitational force at a black hole surface is so immense that not even light is able to escape gravity's hold. Unlike conventional forces like magnetism, which push and pull, gravity is a consequence of the warping of spacetime. Essentially, gravity originates from how mass and energy cause the fabric of spacetime to alter its shape. We are in what is commonly referred to as the gravitational field. The greater the energy of an object, the more intense its gravitational field, and the more pronounced the spacetime distortion. Now, let's delve into black holes, one of the most extreme phenomena in the cosmos. These objects contain unimaginable amounts of energy and mass packed into an extremely limited space. Due to their tremendous mass, the gravitational field of a black hole becomes extraordinarily powerful, creating a pronounced spacetime continuum warp. This is where things start to get truly extraordinary. The gravitational pull is so overwhelming that being close to a black hole results in the formation of an event horizon. This event horizon isn't a physical wall but rather a region where space gradually bends, forming an invisible boundary, a point of no return. Once something, whether a spaceship or even light, reaches this limit, it can never escape the black hole's grasp. The event horizon acts like an invisible force field, trapping everything within it, including light, which is normally considered the fastest entity in the universe. To emphasize just how extraordinary this phenomenon is, imagine turning on a flashlight. The light rays travel at an astonishing speed of around 300,000 kilometers per second. However, if you found yourself inside a black hole, the speed required to escape its pull would exceed the speed of light, something currently deemed impossible according to modern physics. At the core of a black hole, we encounter what is known as the singularity. This is the location where all of the black hole's mass and energy, no matter how immense, get condensed into an infinitesimally small point. The singularity is like a giant cosmic object with a gravitational pull and curvature that extend beyond comprehension. In fact, the singularity possesses infinite curvature and gravity, which is a truly fascinating concept. When attempting to understand the singularity as we currently comprehend it, physics breaks down. We don't have a clear understanding of what happens there, almost as if the laws governing our universe take a hiatus or vanish altogether, leaving us completely bewildered. Researchers are still looking into this enigmatic region in hopes of unraveling the secrets hidden deep within black holes. To comprehend the formation of black holes and what transpires within them, it is essential to examine the life cycle of massive stars. These real cosmic powerhouses are massive stars driven by intense nuclear fusion reactions occurring in their cores. Their energy comes from the fusion of hydrogen and helium. During this process, two hydrogen atoms meet and combine to form a single helium atom. As long as the star has sufficient hydrogen to sustain the fusion process, it can fuel its brightness. However, stars have an insatiable appetite and a constant push to continue the fusion process. When the star's core hydrogen is exhausted, the star gets creative and begins combining heavier elements like helium, carbon, and oxygen. Each subsequent fusion reaction produces less energy than the previous one. To make up for this energy loss, the star has to work harder, burning fuel at an increased rate and raising its internal heat to maintain its delicate equilibrium. Eventually, a critical point is reached where the star can no longer fuse any additional components. At this point, the star collapses under its own gravity in a spectacular implosion. It is during this collapse that a black hole is born, and the core that's left behind becomes the heart of the black hole, known as the singularity. Scientists recently directed their cutting-edge telescopes toward the interior of a massive black hole found at the center of a galaxy about 800 million light-years away. Black holes are notorious for their insatiable hunger, devouring anything that ventures too close. In this instance, the black hole's cosmic feast was remarkable. As matter fell into the black hole, it was heated to incredibly high temperatures, reaching millions of degrees. The scorching gas produced a glowing corona around the black hole, forming an intense cosmic halo. The resulting X-ray flares, akin to cosmic fireworks generated by the superheated gas, did not disappear into the depths of the black hole. Instead, they encountered an unusual cosmic bounce. These flares reflected off the gas behind the black hole, defying the laws of physics as they confronted the massive black hole's magnetic and gravitational fields. Remarkably, they survived the black hole's immense forces. The flares were bent by magnetic fields and gravity, sending them on a spiraling trajectory that ultimately reached our telescopes. This groundbreaking discovery marks the first direct observation of light coming from a black hole's interior, providing additional confirmation of Albert Einstein's theory of general relativity, which predicted that gravity could alter light. This observation confirms Einstein's insight, proving his brilliance once more. But how did this remarkable discovery come to light? The story revolves around two impressive space telescopes, the European Space Agency's XMM Newton and NASA's James Webb Space Telescope. These telescopes were focused on a supermassive black hole and observed quite a spectacle. Over several days, they recorded fascinating X-ray flares emitted by the superheated corona surrounding the black hole. However, things took an intriguing turn when researchers delved deeper into the data and noticed something unusual. Some flares were different in color and arrived later than others. This prompted a new inquiry into why some flares arrived later and displayed various hues. Eventually, it was revealed that these X-ray signals originated from the black hole itself. This unexpected observation prompted the study's researchers to carry out a thorough analysis using complex cosmic calculations. As they pieced the data together, a remarkable phenomenon emerged, a phenomenon known as a light echo. Extremely powerful gravitational forces are so intense that even light cannot escape. However, in the vicinity of a black hole, a whirling disk of material, such as gas or dust, is frequently drawn in. This material heats up due to immense gravity and emits X-rays and other forms of radiation as it spirals inward, creating a glowing ring known as the corona. What are your thoughts on this discovery? Let us know in the comments. If you enjoyed this video, remember to hit the like button and subscribe to stay updated on similar content. Thank you so much for watching, and we'll see you in the next video. The intriguing nature of black holes lies in their ability to bend the very fabric of space and time. This bending is more than just a theoretical concept. It is a reality confirmed by a variety of astronomical observations and scientific advancements. Recent breakthroughs in black hole studies demonstrate how little we actually understand about these cosmic giants. Even though we now know a great deal about how black holes behave on a large scale, their fundamental mysteries remain largely unsolved. The curiosity surrounding the singularity at the center of a black hole continues to grow. The singularity represents a point of infinite density, where the gravitational force becomes so strong that space and time themselves cease to behave in any recognizable way. This presents an intriguing paradox for physicists. The physical laws that govern our understanding of the universe do not appear to apply under the extreme conditions of a singularity. This is one of the biggest puzzles in theoretical physics, as it suggests that our current models, particularly those based on both quantum mechanics and general relativity, may be incomplete. One of the most important characteristics of black holes is their significant effect on spacetime. This effect, referred to as gravitational time dilation, means that time moves differently depending on how close you are to the black hole. The closer you are to the event horizon, the slower time appears to pass relative to an observer farther away. This effect has been demonstrated by observing objects near black holes and analyzing how time moves around them. For example, satellites orbiting Earth experience a slight difference in the passage of time compared to objects on Earth's surface due to Earth's gravity. However, the effects near a black hole would be far more extreme. The discovery of light echoes is an extraordinary step in confirming theories about how black holes interact with their environment. Light echoes occur when light bounces off objects surrounding a black hole, especially those located in the accretion disk, the spinning, gas-filled, glowing mass and debris being pulled into the black hole. This phenomenon is analogous to sound echoes bouncing off surfaces in our surroundings. By studying the timing, color, and behavior of these light echoes, scientists can infer properties of black holes that were once unimaginable. Furthermore, the study of supermassive black holes, which reside at the centers of most galaxies, is becoming increasingly significant in understanding the structure and evolution of galaxies. Black holes frequently hold the key to understanding why galaxies take the shapes they do, how they evolve over time, and why some galaxies, such as our Milky Way, harbor such massive cosmic objects at their centers. In fact, the supermassive black hole at the heart of our galaxy, Sagittarius A*, has been the focus of numerous observations. Despite being millions of times more massive than the Sun, this black hole has very little impact on the Milky Way compared to the way smaller black holes affect their surroundings. As scientists continue to refine their understanding of these massive objects, new questions arise. What caused these enormous black holes to form? Did they originate from massive stars collapsing? Could there be additional processes at play? Some theories suggest that supermassive black holes could be the remnants of primordial black holes, which are thought to have formed just after the Big Bang. Others propose that they may have developed through the gradual accumulation of matter over billions of years, starting as smaller black holes. Black holes' gravitational force also leads to a phenomenon known as spaghettification. This occurs when an object moves closer to a black hole, and the difference in gravitational force between the front and back of the object stretches it to an extreme degree, much like spaghetti. While this might sound like science fiction, it is a very real process that happens in the extreme environments around black holes. Black hole research is not only a scientific endeavor, but also a philosophical question. They raise profound questions about the nature of reality, the limits of human understanding, and the very fabric of the universe. How can we comprehend an entity that bends time and space? What happens beyond the event horizon? Can we ever truly know the answers? These questions challenge us to rethink our understanding of the universe at its most fundamental level. In the future, as new technologies and more powerful telescopes are developed, our understanding of black holes will continue to evolve. For instance, the Event Horizon Telescope made history in 2019 by capturing the first-ever image of a black hole shadow, offering a glimpse of the giant black hole at the center of Messier 87, M87. As these advancements unfold, we may uncover new mysteries that challenge everything we thought we knew about the cosmos. As researchers continue to explore the immense depths of space, the role of black holes in the universe will remain one of the most enthralling and enigmatic subjects in all of science. Their study not only pushes the boundaries of our understanding, but also reminds us of how much we still have to learn about the universe. Each discovery brings us one step closer to comprehending the true nature of black holes and the incredible forces that control the cosmos. One of the most thought-provoking aspects of black holes is their potential connection to the fundamental properties of time and space. Black holes represent a boundary where our comprehension of traditional physics, such as Newtonian mechanics, and quantum physics collide. The study of black holes continues to be a fascinating journey into the unknown, promising new revelations about the very nature of reality itself. As technology advances, scientists are uncovering new insights into black holes that were once thought to be beyond the reach of human comprehension. The next frontier in black hole research involves a deeper investigation into quantum gravity, a field that seeks to unify Einstein's theory of general relativity with quantum mechanics, two pillars of modern physics that currently remain incompatible. The paradox of information loss. One of the biggest mysteries surrounding black holes is the information paradox. According to quantum mechanics, information about a system can never be completely lost. However, when matter falls into a black hole, it appears to vanish beyond the event horizon, seemingly erasing all traces of its past state. Physicist Stephen Hawking proposed that black holes slowly evaporate over time through a process called Hawking radiation. This radiation suggests that black holes might eventually disappear, but it raises a troubling question. What happens to the information that was inside? Does the information somehow escape with the Hawking radiation? Is it imprinted in the event horizon in some unknown way? Could it be stored in a parallel universe or an alternate dimension? Recent research suggests that quantum entanglement might play a role in resolving this paradox, but the full answer remains one of the most profound unsolved problems in theoretical physics. Wormholes and the possibility of interstellar travel. Another fascinating idea associated with black holes is their potential link to wormholes, theoretical passages through spacetime that could provide shortcuts across the universe. According to Einstein-Rosen bridge theory, black holes could be connected to white holes, hypothetical regions where matter and energy emerge rather than being trapped. If this were true, black holes might not just be cosmic devourers but could also serve as gateways to other regions of the universe, or even to different universes entirely. While no evidence for wormholes has been found, they remain a captivating subject in physics and science fiction, inspiring ideas about future space travel and the possibility of faster-than-light transportation. Black holes and the fate of the universe. The study of black holes is also critical in understanding the ultimate fate of the universe. Some cosmological models suggest that as black holes consume matter and radiate energy over trillions of years, they could play a role in shaping the end of cosmic evolution. There are several possible scenarios. 1. The Big Crunch. If the universe stops expanding and contracts, black holes could merge and eventually lead to a singularity, potentially triggering a new Big Bang. 2. The Big Freeze. If the universe keeps expanding indefinitely, black holes will slowly evaporate, leaving behind a cold, dark cosmos where no new stars can form. 3. The Big Rip. Some theories propose that dark energy could accelerate the universe's expansion so drastically that even black holes would be torn apart. Understanding black holes could help answer fundamental questions about whether the universe is finite or infinite, cyclical or destined for an eternal void. The role of AI and advanced telescopes in black hole research. With the advent of artificial intelligence and increasingly powerful telescopes, our ability to observe and analyze black holes is improving rapidly. AI algorithms are being used to enhance the resolution of black hole images, like those captured by the Event Horizon Telescope, detect patterns in gravitational waves produced by colliding black holes, simulate extreme environments near singularities, helping us test new physics beyond Einstein's equations. Future missions, such as NASA's Lynx X-ray Observatory and the Laser Interferometer Space Antenna, LISA, are expected to revolutionize our understanding of black holes by providing unprecedented insights into their behavior, structure, and interactions with their surroundings. Conclusion: the ever-growing mystery of black holes. Black holes continue to challenge our understanding of the universe, time, space, and even reality itself. As we push the boundaries of science and technology, we may soon unlock some of their most profound secrets. Each new discovery brings us closer to answering the biggest questions in physics. What happens inside a black hole? Can we harness their energy? Do black holes connect to other universes? Will we ever travel through a wormhole? While we don't yet have all the answers, one thing is certain: black holes will remain one of the most fascinating and mysterious objects in the cosmos for generations to come.